the enterocyte. The usual process is Fe2 plus through DNT1. In other words, the 2 plus state of iron through the divalent metal transporter 1. We're going to talk about heme versus non-heme iron in 1 second, but we can use a peroxidase, or in the opposite, a metalloreductase, to convert non-heme iron, which is 3 plus, which is usually found in plant products, to heme iron, which is 2 plus, and send it through the divalent metal transporter. When they tell you that you should eat iron with vitamin C, especially non-heme iron, it's because our vitamin C, our ascorbic acid, can go ahead and reduce that 3 plus iron to 2 plus iron, which allows it to go through, so we don't have to use our own enzyme. Just the interaction in the form, it's not really chyme anymore, but whatever's hanging out in the intestine can have its own redox reaction, and then you don't have to convert it using an enzyme. If it's not stored in the cell or in ferritin, the iron is exported through ferroportin. And I'll put Fe2 plus just a little bit clearer. Then, cephastin and or ceruloplasmin convert iron 2 plus to iron 3 plus, and iron 3 plus binds in the bloodstream with carbonate ion to transferrin. After that, to enter the cell, transferrin binds to transferrin receptor. Once inside the cell, the transferrin-containing endosome lowers the pH and releases iron 3 plus. The metalloreductases convert iron 3 plus to iron 2 plus. Iron 2 plus exits the endosome via the divalent metal transporter 1. In the cytosol, iron 2 plus can be stored in ferritin. So that means the H, that says H. H subunit oxidizes iron 2 plus to 3 plus, and the L subunit stores 3 plus in the core. In the cytosol, iron 2 plus can also be exported to the bloodstream using ferroportin and a peroxidase for binding iron 2 plus to transferrin as 3 plus. Remember, ferroportin exits 2 plus iron. Ferritin can be broken down to liberate stored 3 plus iron, which can be converted to iron 2 plus and sent out of the cell via ferroportin, which then can also use those oxidase enzymes to allow it to bind to transferrin. So that's a lot. Like, I realize this is just a lot of stuff. So we've done the little pieces of how each of this works, and this is how the whole thing works going together. This is the cycle of the way you can go back and forth with iron. We do a great job evolutionarily by conserving and developing these mechanisms whereby we keep iron 2 plus from running amok and destroying our cells, but we also do a good job of recycling because iron is so important, and we don't necessarily take in, I think the book said something about 14% of the iron that's in our diet actually comes in. So we can recycle this iron for